In the previous example, I said that you should always think about compositions as a chain of functions. And there's a reason that you should always draw this diagram when you think about compositions, because it tells you exactly what you need to do. You need to first map something underneath f, the first function, and then you need to be able to map that, whatever it gives you, underneath another function, g. So given two functions, f of x here and g of x, let's give the domain of the composition g of f of x. So we're going to take x, map it underneath f first. We'll get f of x, and then we will map f of x underneath g, and we will get g of f of x. So in order to make this first jump, we need to map x underneath f. Well, f of x is a polynomial, second degree. Its domain is all real numbers. So far, there's no stipulation on x. X can be anything. In order to make this jump, we need to be able to map f of x underneath the g function. So what kind of inputs can the g function accept? We're only allowed to take the square root of positive numbers. We need 10 times f of x to be greater than or equal to 0. Right now, why did I write f of x here instead of just x? Because look at your picture. You're trying to map f of x underneath the g function. So if you plug f of x in for those x's, that would be g of f of x. So this is what we need to happen. Let's figure out what that means about x. We need 10 times f of x to be greater than or equal to 0. F of x is 2x squared minus 8x. We need 20x squared minus 80x to be greater than or equal to 0. Okay, in fact, I don't know why I distributed that 10. I want to factor out a 20 now. In fact, let's factor out a 20x. No, just a 20. All right, 20 is always going to be greater than 0. This has to be greater than or equal to 0. All right, now when is this function greater than or equal to 0? We can pull out an x and write this as x times x minus 4. Therefore, it's a quadratic with zeros at 0 and at 4. And it's concave up. So this is greater than or equal to 0 over here and over here. So we need x to be less than 0, or sorry, less than or equal to 0. Or we need x to be greater than or equal to 4. For these values, this composition will make sense. So that is the domain.